Welcome back. Today we're going to be looking at systems of linear equations in two variables. It's going to be finishing off our year in Chapter 7. A quick note, there's not going to be a test in Chapter 7. It will be tested material on the final exam, but Chapter 7 itself doesn't have a test. It's only 2 sections, and it'll be covered on a comprehensive final, which will test everything that we've done this semester. So as we get started, let's look at how to apply pretty much everything we've learned this year and wrap it up into systems of equations, which is more than one equation with an x and a y. All right, so we're going to get started, and I'm going to look at this picture for just a second and show that the solution of a system of linear equations or lines is where they intersect, like in that picture. You'll notice that parallel lines have no solution, and you'll notice that coincident lines have infinite solutions, or lines right on top of each other that are the exact same line, even if the equation looks a little different, are going to have all infinite solutions as long as the line is. Any point on that line then is a solution. So first thing we're going to do is just check and say, hey, I'm going to give you a point, check and see if it's a solution. Easiest way to do this, and the only way really to do this, is to grab that point and plug it in. And remember, a point is always of the form x comma y. Sometimes it's x1, y1, but because they just gave us 1 point, we've got x comma y. So we're just going to plug that point into the x and the y value for each of them. So the first one we're going to have is 5 times 8 minus 4 times 5. And that is going to equal, and you could equal 20 and put like a question mark, seeing does it equal, or you could just leave it blank and we could solve it and see, does this equation equal what it says it should. So 5 times 8 is 40, minus 20, that is 20, equals 20, check. So it is a point on this graph. 8, 5 lies on the blue graph. But that doesn't mean it's a solution of the systems. We need to go and check. So we'll do it one more time. We'll say 2 times 8 plus 1 equals 3 times 5. And we'll see that we're going to get 16 plus 1 equals 15. So 17 equals 15, and no, it does not. And so we've got ourselves a problem. It does not fall on the second graph, or 8 comma 5 is not a point on the red graph. And because it's not on both, it is not a solution. We could go and find that solution, which we'll do here in a little bit, but because this question just has to determine whether it was or was not a solution, we can say it's not a solution. All right, let's keep going. We're going to do 3 different ways of solving these, and then we'll call it a day. We're going to do it by graphing. I think we're going to do it by substitution and by addition. So first thing we're going to do is graph these equations. A couple different ways you can graph this. If you look at the completed notes, you'll see that I turned them all into y equals form. I think this time I'm just going to find the intercepts and graph them with straight lines. So we'll keep that one blue again. Top one is blue. And I'll say, okay, I'm going to find the 2 intercepts because it's going to be pretty easy. If x equals 0, that term goes away, right? So if we look at the term 0, comma, then we'd be left with, here, I'll do this over here so you can see the work. 2 times 0 minus 5y equals negative 25. Negative 5y equals negative 25. Y equals, divide both sides by 5, and you get 5. So we have a point 0, comma 5 for the blue line, and then we could do the exact same thing on the other side. Ooh, and that's not going to be a pretty point. I'll do it anyways. Plug in 0, so 2x minus 5 times 0 equals negative 25. 2x equals negative 25. X equals negative 25 over 2. 12 and a half. That's not a very pretty point, so we might have to go and try something else. But we have the point 0, comma 5. And if we can find the slope, we could plot that pretty fast. And so I might do a little rewrite to find the slope. I'll stay over here on the blue side. Let's find slope real quick. Let's do 2x minus 5y equals negative 25. Remember, in order to find slope, you want to find the y equals mx plus b form. And so it's going to end up looking like y equals negative 2x, move that 2x over, minus 25, negative 5y, divide by negative 5 to get y by itself. And we're going to get y equals 2 over 5x plus 5. Well, there's our plus 5, so our y-intercept was good. And the 2 over 5 means you're going up 2 and over 5. And so we should be looking at that point right there. And once you have 2 points, you can draw a straight line. You could use your ID, your school ID. You could keep going and just dot a bunch of points. There's a lot of different ways to, if you wanted to just keep going and go up 2 over 5, over 5 down 2, over 5 down 2, you could totally do that. So there's our first line. Now we need to find our second line. We'll make this the red line and do it over here. We might do the same thing because I don't think that 4 is going to divide nice and neat over that 35. So we'll go back and do it the same way where we solve for the y equals mx plus b form. And so over here, I'm going to get 5y equals, I'm going to move that 4x over, positive 4x plus 35. Divide by 5, divide by 5, and I'm going to get y equals 4 over 5x plus 7. So we've got a different y-intercept of 7. And we've got a up 4, 1, 2, 3, oh, I'm going to have to go over. We've got an over 5, 1, 2, 3, 4, 5, and down 4, 1, 2, 3, 4. Oh, and look at that, it hits that line already. I'm going to do it one more time though, over 5, down 4. It's going to put me right there. I'll draw another line connecting all 3 of those dots. And we see our intersection point is this point in the middle, which looks like it's negative 5, comma, 3, which means our solution, like we checked earlier, is negative 5, comma, 3. And if you want to go back and look at the last section up above, you can notice how if you plug that point back in to both equations, you should get true statements. And if you don't get true statements like earlier, it's not a solution. So that'd be a good way to check your work, would be to take that point and go back and plug it into both of those equations and see if they result in true statements. So that's by graphing. You're just graphing 2 lines and finding where they intersect. Now sometimes they won't intersect on a nice neat point on the graph, and if they don't intersect on a nice neat point, then you might have to do a little more work to find it, which is what we're about to do. So the first way is by substitution, and this is if you can get x or y by themselves alone pretty easily. So for instance, they've already given us x by itself. If we wanted to get y by itself, we could just get rid of that 3, subtract it over. But if you have x or y by itself alone, substitution is a pretty easy way to solve for that point. So the first thing I'm going to do is I'm going to say, well, look at this x. I've got an x down here in this problem as well. Wouldn't it be nice if I just swapped those out? Because x is technically the same thing. And so I'm going to rewrite the bottom equation, 4 equals 3. But instead of x, I'll do it in parentheses. I'm going to write this side of the equation, y plus 3, because we know those are the exact same thing. Minus 2y. And now I've got an equation with just y's, and I can solve it out. Remember that DCMAM, don't call me after midnight. Distribution's always first, so distribute. 4 equals 3y plus 9 minus 2y. Do a little combining of like terms to make our jobs a little easier. 3y minus 2y is regular y, y plus 9. Move the 9 over and you get y equals negative 5. Boop, 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 boop. That's not a solution set, that's just one half of it. That's just the y value. In order to get the solution set, we're going to have to plug it into either. Remember, because we're solving for the solution, or we're solving for where these 2 equations equal each other, it doesn't matter which one you plug it into. They should give you the same result. Matter of fact, if you go and plug it in and you get 2 different x's, then you've messed up somewhere earlier and you've got the wrong point. I'm going to pick the easier one just because I think it's a little easier. I'm going to say x equals, now instead of y, I've got this nice number for y, negative 5 plus 3, which means that x equals negative 2. And now we've got a solution set of negative 2, comma, negative 5. Remember, that's a solution set because it's got an x value and a y value, and if you want to check your work, go back and plug that x value and y value into the original equations, and they should equal true statements. If they're not a true statement, like you end up with 3 equals 17, then you've messed up somewhere and go back and look, or there's no solution. All right, one more type of method, and then we'll call it a day, is addition or combining. This one's, well, they've given us one where it's actually kind of easy to get y by itself, but we'll still do it. Sometimes this is beneficial if you can't get y by itself very easily because everything's prime or odd, and it's hard to divide it out with getting a lot of fractions. And so this one, what we're going to try to do is make these match. And it doesn't matter where you make them match, on the x line or the y line, but we're going to try to make them match. So the first thing we're going to do is we're going to make sure they're written over each other. So see how that's the x column, kind of? See how that's the y column, kind of? And then on the other side, we put the constant column. It's like general form of an equation. As long as they're in the right column, then we're going to look and say which two would be easier to match. Which one would be easier to get the exact same coefficient? So 2 and 3, we'd have to multiply by 3 and 2 to get 6. So that would be like multiplying by 3 all the way across and 2 all the way across, and we get 6. But instead of doing that, I think the 7 wouldn't be too bad. I'm going to multiply all the way across by positive 7. I'll show you why I'm going to do that in a second. But the reason we're picking it is to eliminate these y's so we can get x by itself. So if I multiply across by negative 7, which mathematically actually we're multiplying both sides by 7, which is allowed because we're technically just multiplying if you divide it out by 1, and that is a totally allowed math thing to do. So we're going to multiply both sides by 7, and we're going to end up with 21x, remember the distribution, plus 7y equals negative 140? Yes. All right, now I'm going to take the blue equation, or that top equation, and I'm going to write it down right underneath it, making sure the x's are in the same spot, the y's are in the same spot, and the constants are in the same spot. Now I've got two equations, and I'm just going to, because this is the addition method, add them. I'm going to add them straight down the columns and go 21 plus 2 is 23x. I'm going to say 7y minus 7y is 0y, which you don't even have to write. You can make a note that 7, and if you don't get something to cancel out, go back and pick a different coefficient to multiply by, because we want something to cancel out. So 23x equals, negative 138. Be careful with that. It's a little tough. And so then the question to ask ourselves is, how many times does 23 go into negative 138? That's a little bit harder of a math problem. X equals, does 3 turn into 8 anywhere? Negative 138? That's tough. 5 maybe? 5 times 23? 15, 108? No. Maybe 6? 6 times 3 is 18. That's 12, 13, 1, 3. Hey, there it is. Look at that. Okay, so 138 divided by 23. Since we don't have a calculator, sometimes you got to go through and do it the old-fashioned way. 23 times negative 6 is negative 138. X equals negative 6. All right, so now that we've got our x value, we can plug it into either of the two equations for our y value. I'm going to use the red one because it looks a little easier. So it's going to be 3 times negative 6 plus y equals negative 20, which means that y equals, move that 18 over, plus 18 plus 18, negative 2. So y equals negative 2. We've got ourselves a solution set of negative 6, comma, negative 2. Awesome. Those are the ways that we know to solve systems of linear equations. Next week we'll be solving, or next video we'll be solving systems of nonlinear equations. Hopefully that makes a little bit of sense, and hopefully you can have a little bit of time to go back and look through as we approach our final exam. All of the videos that we've done in the past, particularly these two, as we're not going to be testing over them, so it's really important that you apply some of these things, practice some of the exercises, and get a good grasp on solving linear equations. Thanks for watching, and I'll see you next time.